water leaks out from an open tank through a hole of area 2 mm square in the bottom. Suppose water is filled up to a height of 80 centimeter and the area of cross section of the tank is 0.4 meter square. Let's draw the diagram simultaneously. Right, this is my tank. Okay, the area of cross section of a tank is given as 0.4 meter square, and there is an orifice whose area is also given 2 mm square, and water is filled up to a height of 80 centimeter. Fine. Now the pressure at the open surface and at the hole are equal. Neglect the small velocity of the water near the open surface in the tank. Find the initial speed of the water coming out from the hole. Fine. Now what I'll do is, let's say this is my point A, this is my point B. Now this is my point A, this is my point B. I'll apply the Bernoulli at A and B. So I have pressure at A plus half of rho VA square plus rho GHA is equals to pressure at B plus half of rho VB square plus rho GHB. Okay, now we know that pressure at A and pressure at B are same. That is given over here, that the pressure at the open surface and the hole are equal. And of course it is given that small velocity of the water near the open surface, we have to neglect it. So the velocity at A has to be neglected. So this is also removed. Now I do have rho G HA minus HB is equals to half of rho VB square. Rho is cancelled. This HA minus HB is my this height. Let it be small h. Okay, so I have G into small h into 2 is equals to VB square 2 times. So VB comes out to be under root of 2GH. That is my answer for the first part. Okay. Now here the hole is made at the bottom, so the value of H will be equal to capital H. So just substitute the value, that is 2 into 9.8. Small h value is equals to 80 centimeter, so that will be 0.8. So the velocity of efflux comes out to be 4 meter per second. That is the answer. In second part, I have to calculate the volume of the water leaked out during a time interval dt after the height remained is h. So if the height remained is h, the velocity of efflux, that is the velocity at point B, is given by under root of 2gh, and we know that the volume flow rate is given by area into velocity. So the area of the orifice is, let's say, small a, and the velocity is under root of 2gh. So this is my volume flow rate, that is dV by dt. So the volume that is flowed in a time dt is given by A into 2gh to dt. Okay, now it can be, this is my rate of change of volume, I mean the rate of flow rate of volume through the orifice, and this will be also equal to the rate of flow of volume, I mean the rate at which the volume is flowing from the point A. It can be written as area of cross section into the velocity of the top surface, that can be written as dH by dt. Okay, so what I get is area into dH by dt is equals to A times of under root of 2gh. Okay, so just integrate it. I have A under root of 2g dt by capital A is equals to dH under root of h, and the value of h varies from, let's say, h1 to h2. So I do have integration as 2 times of under root of h2 minus under root of h1 is equals to A into root 2g by capital A into t. So this is my answer.